Now that we know how to determine if a given point is a solution to a system, and we know how to look at a graph and find the point, now we want to be able to do that from an equation. So there's three ways to solve a system of equations given an equation. We can look at graphing, using substitution, or using elimination. Substitution and elimination are going to be the preferred methods, but we'll start with graphing. And the reason they're the preferred methods is because graphing is really only useful if we get whole numbers or integers in our solution set. But let's go ahead and look at graphing. So step one, we want to be able to graph, so we want y equals mx plus b form. We want to graph all the equations, and we're just going to name that point where they intersect. So looking at example 1, I have two equations. I have equation 1 and equation 2, neither of which are in y equals mx plus b form. So I'm going to go ahead and take equation 1, and I'm going to go ahead and get it in y equals mx plus b form by first subtracting 6 from both sides, and then dividing both sides by 2. And remember that both of these terms are divided by 2, so I get 2x minus 3, so I have a y-intercept of negative 3 and a slope of 2 over 1. So plotting that, I'm going to start at negative 3, I'm going to rise to run 1. Now I know that I only need 2 points to make a line, but because I'm going to be picking the point where they intersect, I want it to be a little more accurate, so I'm going to do a bunch of points. And then I remember I can also go down 2 and down 1 since a negative over a negative is positive. So down 2, back 1. So there is my first line, and I should be using a ruler, but again it's hard with this program. And then doing the same thing with equation 2. I'm going to first go ahead and subtract x from both sides. And then divide by that negative 1. And I get y equals negative 1 plus x, because again both terms are divided by that negative 1. So I have a y-intercept of negative 1 and a slope of 1 over 1. So starting at negative 1, I'm going to rise 1, run 1. Rise 1, run 1. Rise 1, run, and look at that, there's my point of interception. And so I'm going to go ahead and connect these with a, oh actually, I see I missed a point, so I'm actually going to erase that because I'm off a little bit. I'm going to go back and regraph that blue one. So I start at negative 1, up 1 over 1, up 1 over 1. I had went up 2 at one point. There we go, and I already found my point of intersection. So I draw my straight line through. Again, using a ruler would help with that. And now the last part is I name my point of intersection. So it looks like they intersect at this point right here. And so naming that, it looks like I go over 2 and up 1. And I could always check that if I wanted to by plugging it into both equations and making sure it makes both equations true. I'm going to go through example 2. Example 2 is a good one for you to watch with me, and then example 3 is a great one for you to pause the video and try. So on example 2, equation 1 and equation 2, same thing, I want them in y equals mx plus b form first, so I'm going to take equation 1 and subtract the 2x, and I will get y equals 1 minus 2x, so I will have a y-intercept of 1 and a slope of negative 2 over 1. So I'll go ahead and start at 1. And I'll go down 2 over 1, down 2 over 1, which again, remember, is the same thing as going up 2 and back 1 because it doesn't matter which term the negative is on. And then doing the second equation, I'm going to first subtract 3. And I'll have negative 3y equals 6x minus 3, excuse me. Let's see, so making my step a little clearer, I subtracted 3, giving me 6x minus 3. I'll divide by negative 3. Again, both terms are being divided by that, giving me negative 2x plus 1. So my y-intercept is 1, my slope is negative 2 over 1. So I go up 1. And I go down 2 over 1, and I start to notice that, hey, they're all lining up. Actually, if I go back and look closer, my equations were the same, so when I draw that line in, it overlaps, and I know that same lines mean there are infinitely many solutions. And as I said before, the third example is a great one for you to pause and try. Okay, now that you had a chance to try one on your own, let's see how you did. So I have two equations. The first one is already in y equals mx plus b form, so I don't have to do anything to it. I can go ahead and graph that. Oops, not 2, 1. And I have a y-intercept of -2. And I'm going to rise 1, run 1, rise and run, rise and run, rise and run. 1 over 1 is the same thing as -1 over -1, so I can go down and back, down and back. And I can go ahead and connect these with a straight line. And then doing equation 2, I will have to rearrange that one. So I'm going to go ahead and subtract 2x to begin with. And I'll have 2y equals 4 minus 2x. And then I have only one more step. I'll divide by 2. Again, these are both being divided by 2, so I get y equals 2 minus x. So I have a b of 2 and an m of -1. So I will start at a y-intercept of 2, and I will go ahead and go down 1 over 1. And down 1 over 1. And it looks like I found my point of intersection. So drawing in my graph and stating or naming my point, it looks like I went over 2, up 0, so they intersect at the point 2, 0. So real quick summarizing my steps, I'm going to bounce back up here. All we want to do is make sure we're in y equals mx plus b form, graph all of our equations, and then don't forget to name the point. Bring these notes in with you so you can use these as an aid as you're working through your practice.